In this video, I'm going to show you how do we build a very simple internet using the seed emulator. And this is going to be a very tiny internet. Really, the purpose is to demonstrate how you can write a simple Python program and using the seed emulator library and to build a simple internet emulation. Just give you a little bit of background. Now, internet, that word has two parts. The first part is the net. So that's the network part. You need to have a network. Now, on the larger scale, we're not talking about this individual network. We really talk about autonomous system, and those are the unit and on the internet. Inside autonomous system, you have many networks. But at the internet level, we're going to actually look at the autonomous system. And then there's the inter part. The inter part is how do you connect those networks together? How do we connect those autonomous systems together? There are two types of the glue. One is the hardware, and that means you need to have a cable connecting them, or you have this wireless connection. Okay, so that is the hardware part. Then there's a software part, which is a BGP, and they will have to talk to each other and to agree that we're going to actually connect to each other, and that is a BGP. There are different types of autonomous systems. Some, and they are large, they are national backbone, and they will provide a transit service and to the other people. They will actually pull the traffic, your packet, from one place and to another place, and even to another country. And those are the transit. There's another type of the autonomous system. They just end the customer. They don't provide a transit for others. And they will use internet, and that's called a stub. So the traffic will come in. They will not be handed over to other autonomous system. They're going to be consumed by what is inside. And we're going to build a very small internet, because we do have an example called the mini internet, so I'm going to call this one nano internet, which is even smaller. And that is in the example 820. So if you look at our GitHub repository, inside the example folder, you're going to find us 820, and you're going to see the code in there. This is very simple. We only provide this one transit and then three stub autonomous systems. Now, first, you're going to initialize. We're going to actually just import all the libraries from this project. After you import that and to initialize, you just create an emulate object, and then you create the first layer, the base layer. The base layer is what consists of the internet. Now, on top of base, we're going to create those physical nodes. Now, the first thing we need to do is we're going to create internet exchange, and because that's where the network are connect to each other. So those are the internet exchange, and we're going to create two. One is called 100, the other one is called 101. Those are the internal names, and that's the internal identifier. Now, if for the visualization, and you can customize. For example, I actually using the set display name and to customize its name and to New York and to Chicago. Okay, so that's what you're going to see here. If you look at my map here, and this is in the emulator, I do have these two internet exchange here. You can see, and this is where the two autonomous systems connect to each other. And here, these are the three autonomous systems connect to each other. And the names are actually put on the map. I will show you how do we get this map to show up. And next thing is we're going to create a transit. And this is the large autonomous system connecting different internet exchange with another internet exchange. So we're going to provide one called autonomous system 3. And inside of this, we're going to create three internal networks. Okay, and remember the autonomous system, especially the larger one, and in order to connect this computer from different city to another one, they will have to have an internal network to provide those connections. And in this emulation, we just provide a very, very simple topology, a linear structure. So here, and you can see we do provide the net 0 and net 1 and net 2. So this net 0, net 1, net 2. And here, I also create a router called R1, and you can see R1. R1 is going to put on here, and R1 is going to join two networks, Net 0 and Internet Exchange 100. So here it's going to actually Internet Exchange IX100. It's going to connect to here. The R2 is going to be created, but R2 is going to actually connect to this one. R2 is going to be here, also connect to Net 1. And then R3 is going to connect to this one and connect to here. It's just a very simple linear structure. And then the final one, R4, is going to connect to this one and connect to the Internet Exchange 101. And these two, because of their connect to the Internet Exchange, they are the BGP speaker. They are the BGP router. Okay, so we're going to configure this R1 and R3. We're going to install the BGP software on top of that, so they can actually connect with the other autonomous system. Okay, and that's just a simple topology. And you can see here inside our emulation, and that's what you're going to see here. And this is the R1. This is the R1, and this is the R4, and this one is the R2, R3, and you can see the name, and this represents that network. Okay. Now it doesn't need to be linear, and as long as these two BGP speakers can reach each other, that's very important. If they cannot reach each other, they cannot exchange information, because this BGP speaker is going to collect information from this end. This one is going to collect information from that end. And internally, and they're going to exchange information, so the computer at the other end will know how to reach the computer and to this end. Okay, so that is important. Okay, once you have this router, next things, we're going to create a Stub autonomous system. Stub autonomous system, they are just the end customer, and they usually just peer at one Internet Exchange. They could peer with multiple transit, but they usually just sit in one place. In this case, I am creating autonomous system 151, and then I'm creating one network. For each autonomous system, I'm just going to create one network. You can create a multiple one, and you can have a more complicated internal network, and that's just like what we have for the transit. But in this demonstration, I'm only going to create one single network, and with just maybe one or two the node inside this network. And I do need to create a router, BGP router, because for your autonomous system to reach it outside, you do have a BGP speaker and to announce the network prefix on behalf of you, and also collect the information from outside. So we're going to actually join the network 0 and join this Internet Exchange 100. I'm also going to create the host 0 and host 1. I created two hosts and join the network. And for the second one, I want to customize the IP address. Now, when you join the network, if you do not provide the IP address, the emulator itself will actually automatically assign the IP address for you. We do have a convention, and for particular in the autonomous system, what are the IP address? For example, for the 151, the default is going to be 10.151.0.0/24, and this is going to be the default the network provides to this autonomous system. And we use the 10 dot, but then for different autonomous system, and we're going to use a different number here. And this way, we're not going to use the one in the real world to avoid conflict with the real world. But inside this, you can actually customize that. If you do want to use the real world IP address, you can do that. That's no problem. I can also install additional software. Now, all the container that we use in the emulator, they're going to actually build on top of some base. And that base currently it's Ubuntu 20.04. We have already installed some of the necessary software on top of that. But if you say, no, I need some additional software so I can design the lab activity for my class, no problem. You just need to use this API, add software, and put whatever the software you want, and you can install that. As long as it's an open source one, and you can use apt-get to install, and that's no problem at all. Sometimes you do want to run some of additional command when the container starts. We do actually run some of the initialization script, but if you say I want to run some additional command, for example, in this case, I do want to create a new account with some password. And if you want that, that's okay. We do have the API for you to customize that. So we thought about a lot of need, and so actually to enable user to customize and their container image. We may add a new API when we see some of the other needs. But right now, we have some of very primitive things for you to use. You can actually create an autonomous system in a much easier way. We did actually provide some of the utility function for you to use. And for example, in this case, I am creating autonomous system 153 and put a BGP speaker in Internet Exchange 101. I want to create a two host running no service. That's why I put now. If you put the web, and you can actually run web service on top of that. And so that is just a very simple way for you to create autonomous system using our utility functions. We do have a number of utility functions to create the Stub AS, transit AS. That is very convenient, especially if you want to create, let's say, 100 different the autonomous system, and this will make your life much easier. Once you build in that one, you want to get actually a particular node, and you can use the get host, and as long as you know the name, we do have a convention and using the host _0, 1, 2, 3 as the default host name. So that's just in the utility function, and that's what we do. Okay, now we got autonomous system. We got Internet Exchange. The next part is we need to peer them. Autonomous system and other autonomous system, they need to have agreement. They're going to say, I'm going to peer with you. And when they do the peering, there's a business aspect of that because of you could be my customer, I'm your service provider, or we are equal. There are different kinds of relationships. Really depends on how big your autonomous system is. We do provide the emulation of a different relationship. In order to do the peering, and we're going to create a eBGP layer. Our design is a layered structure. Okay, so we are going to do all the peering inside this BGP layer. And then you can say, I am going to peer with 3 and 151 is going to peer. And this is A and this is B. A is going to be the provider of B. So B is the customer. A is the service provider. So in this case, B has to pay A for getting the service. And that's one type of relationship. We also have this API for you to peer multiple, to peer with multiple A, and you can do that, so that make your life easier. In this case, 152 and 153, they're going to be peer, and they're not going to be the customer and the provider relationship. They're just going to peer, and basically they are equal. The understanding peer relationship is not actually that is simple. So I provide this map and to show you and what are the peering relationship. We're trying to emulate what is actually in the real world, and so some of the relationships are captured in this picture. Here, I'm AS150, and then I do have a provider. These are my upstream. I do have a customer, and this is my downstream. I do have my peer, and so how they announce the information, the route to their peers or to their providers, and this just shows their relationship. For example, to upstream, if I'm here and I need to announce to upstream, so A, what do I announce to A if I'm the customer. What you do is you announce yourself, which is S here, and that's what you have, and plus your customer. Okay, so you announce this part, F and G, and to here. You do not announce the route you get from your friends. Okay, because your friends are not the customer of your upstream, and they will not provide a transit for your friends. They are your friends, but they are not your service provider's friends. And so that is the typical provider and customer relationship. And to downstream, so if I announce to the downstream, I will announce everything that I know to my customer, because your customer need to know who you can reach. So whatever I get from other place, I'm going to announce to my downstream. That's why you can see to downstream, I'm getting everything that I get and to my customer. Okay. Now to peers, similarly, I'm just going to actually announce my customer to my peer. I'm not going to announce what I get from my transit and to your peer, because my transit is not going to provide a service to you. Even if I announce to you, it's useless. Okay. We also provide this unfiltered. Unfiltered means I'm going to give you everything. In the BGP, all these relationships are actually implemented as a filter. So when I actually give my route to you, and there's always going to be a filter, and you set the filter, the BGP has no idea who is provider, who is customer, and BGP doesn't understand the business aspect. It is just two peers. When they set up the peering relationship, and they're going to set the peering based on their role in this agreement. Okay, so that is actually what is happening in the reality. We are trying to emulate and this aspect, so it's not just going to be we are peer, but different kind of peers and different type of peers, and that matters. Let's just take a look at the peering, and you can see here. If I point to here, and you can see this BGP speaker peer, let me point to here. You can see this one. If I click on this one, you will see this one appear with this 152, 153, and because these two, 152, 153, they are customer of this transit. So you can see they are here, and later on, if you want to disable them, you can do that. Okay, so that is the peering, and you can see here, and the peering here, you only have one customer, so that's going to be just 151. Okay, if you click on this one, you do have a peer with 153. Okay, and that's what in the code, and you also peer with AF3, which is your service provider. And next part, we're actually going to install some of the web service on some of the node. Now we're going to get into one of the design features in our project. It's a layered design. Now we don't want to put everything in one layer. We want to build different type of things at the different layer. And this kind of layered design, they are widely used by, if you're familiar with the Photoshop, Adobe Premiere. When you compose your picture, compose your video, and you do things at a different layer, eventually merge them. And we are using the same design pattern. So if I want to build a web service, we have a web service layer. If you want to build a DNS, we have a DNS layer. So we have these different layers, and this layer can be moved to a different emulator. So they're not bound and to your base layer. Okay, here I'm creating a web service layer, and then I'm just going to install the web service in this layer. I'm going to install two web server, web 01, web 02. These are virtual node. These are not physical node. Anything at this upper layer, and they are the virtual node. Okay, so now I am going to create this. Internally, we're going to install the web server, initialize the web server for you. If you say, I'm going to use this web service inside of one particular emulator, now you're going to bind them to the base layer, and our binding is for that purpose. So you can bind web 1 to host 0 inside of 151. Okay, so we do have a different a way for you to actually do the binding. So this is just one example. In other videos, I will show you a different kind of a binding. The binding is a very important feature of our project. We do want to allow the user to bind to provide different kind of binding. For example, random binding. So sometimes I don't care where my service should be. Just find one node for me and bind it to that. We can support that. Okay, I will show you in our subsequent videos. Now, after that, everything's done. We're just going to add all the layers. Okay, some of these layers we actually did make a change. These are the essential layer, routing, the IBGP and OSPF, and those are for internal routing. So those are layers that are needed, but we did not actually do any customization. You can just directly add them. After that, you will do the rendering. The rendering will bind the virtual node. We actually do the binding and to the physical node. Now, once you bind them, and you can say, I want to further customize those nodes, change their name to something more meaningful, that's okay. You can just do get binding for this virtual node. That will give you the physical node. The customization has to be done on the physical node. Okay. Now, once you do that, you can say, I'm going to change its name to this for visualization purpose. And you can even install other additional software if you want, but that's another thing you can do. After that, you can save that everything into a file, and you can dump everything into a file, or you can actually eventually compile that into your final emulation file. Now, this is another place where I want to emphasize the composition is independent from the emulation. Okay, this part is emulation. Now, our file, whatever we compose, can be actually used to run on different platforms. So that's where we have this compiler concept. So once you rendered, you want to compile for Docker, that's okay. You just write a Docker compiler, and so you can convert your composition into Docker file. If you say, I want to use the Docker plus the Kubernetes for cloud, you just write a corresponding compiler for that purpose. Or in the future, we want to support other emulation platform. That's okay. You can just write a compiler for that. Okay, that's a very important design decision that we have. We don't want to really bind this composition to a particular emulation platform. It could be for different platform. And these are the example, and that I will show. You can bind to this. You can even just generate the graphics. So this is not for emulation. You just say, I just want to look at what this composition looks like, and we can just dump that into a graphic file, and you can visualize that. Our current main focus are on the Docker, and we did have those, but we are not actually spend too much time at this point. And in the future we will, but right now we actually focus more on the Docker. But our platform can support different emulation platforms. Now, after you finish the programming, and now you can run the program and to generate the Docker file. So that's what we do. The output will be stored in this folder, and you can specify the folder name in the code. And then you can do the Docker build and Docker app, and I will show you here. So here you can see I am in this folder A20, and my program is here. If I just run this, I will be able to generate the output in this folder. Now, if you look at this folder, and you will see, and these are the list of folders, one for each Docker files. Now, if you want to say, I want to look into here, and you can get inside here, and you will see this Docker file here. I won't go through this Docker file, but just give you a sense of what is in there. And all of this is generated based on your program. Okay, so, and there's a lot of things in here, but basically they create the Docker file. we also have this Docker compose file, and that's what you need and to bring up all the entire containers. So you can do the Docker build. In my VM, I have this alias for Docker compose build. So DC build, which I already built, I want to run. And after that, you can do the Docker compose up. I do have this alias for Docker compose up. So DC up, that is going to bring up my container. And everything is going to run. And you can see there's a bird, which is the BGP daemon, and it's going to run, and a lot of things are going to run. And we also provide the visualization part, the front end. And that is inside another folder, which is another container. And you can go to that client folder, just build that and bring that up, and then point your browser to this, because of that container is going to actually set up the web server at port 8080, and just bring that up, and you will see the map. Okay, you just have to wait a little bit until your container start. Otherwise, you won't be able to see all this link because they are not established yet. Okay, but here I have already set up everything. Everything is up. Now, if you don't like the topology, you can just move them around. Yeah, this is underlying the graphic, the software, that is very designed. That's not, we didn't design that. That is open source. We use that to visualize our map. Okay. Now that's what you can see, and now you can just play with that. For every node here, if you look at the hexagon, and these are the host, a circle, and these are the BGP. And you can just click on any of them, you will see something like that. And you can get a terminal, because each of them is a container. It's a machine, and they can run command. You can just get a command line, the terminal, and then you can do whatever you want. Okay. So that's what I want to demonstrate that to you. I will show you some of the feature, very primitive features. In some other videos, I will show you additional features. And for example, here, if I want to see, I want to go to here, and I'm going to launch this one. Okay, I am going to do something. For example, I'm going to run a command. I'm going to pin this host. Let's see what is the IP address here. Okay, 50.80. Okay, that's going to be pin 10.151.0.80. Okay, I do get things, but I don't see the traffic here because I have not set up the filter. Now, if we have installed a TCP dump on all this node, and if you set the filter, they will report their traffic to this map, so you can visualize. So if I say, because pin is ICMP traffic, so I do this one, and you should be able to see the traffic, and we have a very simple topology. So you can see traffic will go from here to here to here, and eventually to here. And if you say, I'm just going to stop that here, peering, and of course you're going to lose connection. And now this BGP speaker is going to say, oh, I don't know how to reach this autonomous system, because this autonomous system withdraw is actually peering, and then everybody's going to withdraw that route, and nobody in the world knows how to get them. Okay, so that is just a very simple demonstration, and you can enable that, and everything is running. You can also go to this BGP router, and you can say, I want to take a look, especially if we want to study how the BGP works, and you can just go inside here. This is the BGP speaker, and you can see, I want to see the route information, and this is the route information that is set on this router. How do we get that? You can do the further look into the BGP table. So here you can run the bird C, which is a client, so you can interact with the bird daemon, which is running on the BGP router. And you can get inside here, and there are a lot of commands you can use, and yeah, you can just look at them. And one of the commands that I use very often is to show route. And that is the route that you actually get from the other BGP speakers. So you can see, so route all, and you will see those are the announcements made by the other. That's how you know how to reach them. Yeah, you can look at the AS path. Yeah, I won't dive too much into here, and just give you a sense of what you can do with that. And this is really just a very simple internet. The goal is to show you how you can build this small internet. Later on, we're going to show you a larger one. We're going to show some more advanced features. Okay, so stay tuned for our next video.